complex familiar question, or maybe unfamiliar because of you involved with a lot of calculations. So I'm going to go through my pre-written answers, solutions for you to digest what I did. So I'm going to go through the questions first. So we got the function, a hill cross-section area is given by this integral. So ABC is unknown. So hx is the distance between the vertical distance. So I'll draw the graph. So this is my graph for hx. So the hx are representing all the distance, vertical distance. The x are representing cross distance. So this x, this is the vertical hx. All right, we're given two conditions. So therefore, we got the x. So we have given two conditions we know. One is when the hill hasn't the lowest position, which is when x equals to 0. So therefore, this domain left hand side, the endpoint is 1.22. The other end of domain is 25 meters high. So these are two conditions we know. So that means when x belongs to 0 and 40, so the range, so this is a domain, y, so the h, sorry, we call h, x belongs to 1.22 and 25. So now we also give you another condition is gradient. First gradient at a stump. There's two stumps. At first stump, the gradient is 0.88. The second stump number 2, is located further up on the hill, but they didn't say what is the second gradient. It's only give you the distance between two stumps is 0.44. All right, so now we're going to predict a surveyor predicts that vertical distance is separated two stumps between 7.5 to 8.5. So that means the survey estimate will predict the distance between the two stumps. So let's say this is stump 1 and this is stump 2. So the height, must be the height is between that. So that means we need to find whether it's the vertical distance between the two stumps. So we're going to calculate to see if it's what's the difference between the two stumps. So we need to find out that we call delta hx between the two stumps. Now the two stumps, the x1, x2, we don't know. So we need to determine what is x1 and what is x2. So we need to determine those points. All right, this is my digested the questions. So now I'm going to solve them. So how do I do that? I'm going to use the difference, the relationship between derivative and integration. So we know if I want to find out the hx, I can differentiate the integral, which is equal to hx. So this is a very important concept. So the hx is a derivative of integration of hx with respect to x. So we're going to do that. So differentiate that. So the answer will be a times by e to the power bx. Where's the b gone? Because b cancelled out. So that's my hx. So I'm going to substitute. First, I'm going to decide what a is. So I'm going to find that a and the b. So these are my coefficients we need to decide. The c is already disappeared because when you differentiate that, c is 0. Oh, when you cancel it out, so c doesn't affect the answer. So we just need to find a and a b. So I'm going to use the condition number 1. So which is the first condition. H0 is 1.22. We substitute into the equation, so we got a is 1.22. So then replace the second condition, H40 is 25. We replace H25. The x is 40, so we decided using the e exponential converted to log. So b will be log divided by 40, so 0.755. So we got a and a b. So now we can write down hx is 1.22 times by e to the power 0.0755x. So this is my equation for h. Now, we need to find out the two x's. So we need the stumps. So when is the stump 1? When the x, the horizontal distance. So how do we know x1? So we need to using the condition of the gradient at stump 1 is 0.86. However, we don't have a differentiation, or we haven't had a gradient. So first of all, we need a differentiator h. So we differentiate h, which is getting second equation. Then we substitute at stump 1. We call h, derivative h is 0.86 substitute. So we will get that to solve for x. So you can see what I did. I just inverse of it. So divided by, then you do inverse function become log. So end up x is 2.233 divided by that is 29.785. At stump 2, we're using the same methods, but stump 2 is a difference between two stumps. The gradient is 0.44. So we add a original 0.86. So end up the gradient difference between the two gradient is 1.3. So we substitute. So that's the second stump gradient. So we substitute into the equation. So we solve for x. So the second x is 35.06 using graphics calculator. Now we're going to do the difference between the two stumps, the heights. So I'm going to substitute, replace those values into my hx. So pretty long process, but I'll take the common factor out to reduce the calculation. So I'm going to do 1.22 times by bracket of that. So I end up is 5.8278. Now the prediction was between the two stumps is 7.5 and 8.5. So that means this is not reasonable prediction. So the prediction of the height between the two stumps is not reasonable. So that's wrap up the solution for this particular complex question. I hope you understand what I have done. So please give us the thumbs up if you understand the question. And also don't forget to subscribe the channel for more videos. I will see you next time. Bye.